So this week's lecture is a little bit of amplifier basics. It's one of these things that often can be taught in other classes, but often that's an elective class. So I know I've seen it previously in like wireless courses because you're interested in RF amplifiers. And a lot of this stuff does carry over to RF amplifiers, except the majority of RF amplifiers at this point seems to be Class A. But we'll talk about the audio amplifiers. We've got not only Class A, which is the simplest one, but also common one, A, B, and D, being the new player that's kind of changing a lot. All right, so quick overview. Going to talk about amplifiers. We'll talk about the linear ones, mostly linear, Class A, Class B, and Class AB. Talk a little bit about those. And then we'll talk about also Class D, which is commonly called a switching amplifier. Sometimes incorrectly referred to as a digital amplifier. And there's a reason for that, but that's kind of, unfortunately, more marketing hype than reality, you know. Then I'm going to start talking about vacuum tubes. The idea of covering these class amplifiers is to talk about tube amplifiers. We could talk about solid state amps, but the circuits as a whole aren't that different. You know, there are different sounds and there are benefits of tube versus transistor, but it's still basic audio amplifiers. You know, it's not like you're comparing this to some VLSI design with, you know, thousands of gates. We're talking very similar things. So we're just going to focus on vacuum tubes because those aren't covered at all anywhere else in the curriculum. And you know, one of my promises to the former head of the department, Professor Sandler, was that I would get vacuum tubes back in the curriculum. You know, so it makes sense. There's still brand new designs based on vacuum tubes coming out every year. There are actually new amplifiers based on old designs. But there is some new research and some new interesting stuff being done. So they are definitely relevant in this course. So we'll talk about the basics of tubes. What's thermionic emission? What's the Edison effect? Where did Edison come into this, you know, history? Then we'll also talk about the basic tubes, triodes, diodes, pentodes, juntodes. And then I'm going to talk a little bit about common tubes, because we're at an interesting point in the evolution of tubes, where you had the early tubes, the 4-pin tubes, and those aren't too common. And then you kind of had the heyday of tubes, and there are a lot of tubes that are very prevalent from that heyday, 12AX7, the 66, and 606. You know, that if you've ever changed tubes on amp, you know these things. There are also kind of post-heyday tubes that are kind of interesting, that they're almost integrated circuit tubes. That you know, you don't get to the point where you get a tube op amp or anything that integrated. But you know, 12AX7 is a dual triode. Well, they came out with triple triodes and other tubes that are triode pentodes that were very useful for a very specific use in television. So you had these hybrid tubes that came out that had their purpose, and you know, of the tubes being reproduced now, it's mostly the common ones, the 12AX7s, the 66s. These earlier ones and the later ones really aren't being produced. And the danger there is you do find a lot of common amplifiers, for instance, Ampeg amplifiers, that have a lot of these later generation tubes. The story I've heard is the RCA salesman must have done a great job at Ampeg, because you know, the part salesman always wants to convince you to incorporate the newest part into your design, and you know, a lot of conservative engineers would want to keep the old parts because they know it. But the newer ones, you know, were slight tweaks and add a little bit more, so you get like the 7027A, which is like a 6L6, but you can run a little higher voltage and get a little more power out. So if you design those in, it's not really that much of a design change, and you can put the 7027 in, and then you can sell it, at higher numbers. You add to the market. But now, since nobody's reproducing them, or maybe they're starting to reproduce them, they weren't too common, people would alter amps to use the common tubes. Usually you can do that. Once we get through talking about what tubes are and tubes do, we'll talk a little bit about circuits. And it's a little more completed than it was when I presented this the last time. It's not yet completed. I've actually added some stuff where I walked through a Fender twin reverb schematic, and we look at the vibro-champ schematic. It's not as thorough as I'd like. You should read the handouts, the photocopies I made there. That covers it in much better detail. That'll give you a better idea of what's going on. And the RCA tube manual, again, is a great resource. It talks about all basic circuits. From what I've heard, and I haven't sat down with all the schematics to look, but a lot of the early tube amps are based on RCA reference designs. Some of the things that are in these handouts are designed straight out of the tube manual, and a lot of those get reused. Because when you come down to it, there really aren't too many ways to build an amplifier. Or practical ways. Okay, so let's go right into amplifier classes. So basically, we talk a lot about amplifier classes, especially with guitar amps. It's discussed very often. People talk about Class A distortion versus Class B, or Class AB distortion, how different things sound, and there's a little bit to that. Of course, when you get down to it, though, really, if you have distortion, you have clipping. If you have clipping, you can't be Class A, because the definition of Class A is that the device is conducting 100% of the time. But, again, you play with words. So you have an amplifier that's designed to work Class A, and though it's not actually operating in Class A, it's actually saturated when it's clipped, it's still a Class A circuit. So we talk about it as Class A. So the basic definitions are very kind of set in stone. They're very rigid if you look at it. Class A means every output device is conducting 100% of the time. There's some controversy as to certain amps. Class B is you're conducting 50% of the time. And then Class AB says anywhere between 50 and 100%. And so there's controversy over something like the certain box amps. They're often described as Class A. Whereas I've seen some analysis that says the output tubes are conducting maybe 80 or 90% of the time. So it's one of these things that, strictly speaking, it's not Class A, because it's not 100%. But it's also not where most Class AB amps. Most Class AB amps are just a little over 50%. So it's clearly more towards Class A than Class AB. But to call it strictly Class A is also not completely correct. So, these are kind of the standards, and these are the amplifiers that we've seen in musical equipment from the 50s, the dawn of really amplifying electronics, up until probably until the 80s or 90s when we see Class A. Class C is something that I'd like to mention, although I don't think I've ever seen it for audio. Class C is actually saying the output is conducting less than 50%. It's a pulse amplifier. Now it's an efficient amplifier, and it's often used in radio in conjunction with a tuned tank output. But it's not worthwhile for audio because it's just too distorted. Class D is an interesting scenario. It's totally different than the others, and it's a switching amplifier. And what it actually relies on something akin to sampling theory and reconstruction. And I have a Simulink model that shows how it works, and I think that's probably actually a better way to illustrate the principles of Class D. For all of you that have come up with Simulink models, so instead of showing a tube schematic or a transistor schematic, I did a Simulink model, and I'll show where things represent the tube or transistor.